Our topic today is matter. So, what is anything that occupies space and has mass and can be perceived by our senses is called matter. So, let's take a water. Water occupies some space, it has mass, and you can touch it, you can see it, so it is matter. You take your pencil box. You can touch your pencil box, you can see the pencil box, it occupies some space on the table, it has mass, and so it is matter. But laughter is not matter. Okay. Composition of matter. Matter is made up of small particles called atoms, molecules, and ions. So, any form of matter is made up of very small particles. These particles are really tiny and they can be of various types. They can be atoms, they can be molecules, or they can be ions. So, what is an atom? An atom is the smallest unit of matter that may or may not exist independently but can take part in a chemical reaction. So, if you start breaking down the matter into very smaller units, you will end up reaching an ultimate small particle, and this smallest particle may have an independent existence, may not have an independent existence, but whenever a chemical reaction will take place, that's whenever a chemical change takes place, it's these atoms which will take part in the reaction or in the chemical process, chemical change. So, it's a smallest unit of matter. The picture which you can see here is a picture of an atom taken from a scanning tunneling microscope. So, that's how an atom looks like if you try to take its picture. So, it's not one atom actually here, it's a cluster of atoms. That's how the picture has come here. A molecule. A molecule is the smallest unit of pure substance that exists independently and exhibits all the properties of that substance. So, a pure substance, the smallest unit of a pure substance, not of a mixture, that exists independently is a molecule. So, a molecule has independent existence unlike an atom, and it will exhibit all the properties of that substance. So, if you have a molecule of water, the molecule of water will show all the properties of the maybe some sample of water, a glass of water. So, their properties will be same. So, the properties of the substance is shown by the properties of the molecule and not by the atom. It can be made up of same type or different type of atom. So, a molecule may be made up of same type of atom or a different type of atom. So, let's see here. Here we have a hydrogen molecule. This hydrogen molecule is made up of two hydrogen atoms. Whenever we represent atoms diagrammatically in our chemistry books while learning chemistry, we always try to represent it by a circle. So, please keep this in mind. A circle is usually used to represent the sometimes the particles of matter, sometimes maybe molecules of matter, and most often it's an atom. So, here what we are representing, each circle, each yellow circle represents an hydrogen atom. Here two hydrogen atoms have combined together to form a molecule of hydrogen. Okay. So, it's the same type of atom. Likewise, you can have a chlorine molecule, you can have an oxygen molecule where two chlorine atoms form one chlorine molecule and two oxygen atoms form one oxygen molecule. Now, here we have a water molecule. A water molecule is made up of two hydrogen atoms and one oxygen atom. So, you can see oxygen atom here is represented by green. It's a little bigger than the hydrogen atom, so we have drawn it big, and here the hydrogen atoms are represented by yellow. So, two hydrogen atoms and one oxygen atom has combined together and formed a molecule of water. So, here you have different types of atoms combining together and forming a molecule of water. So, you can try and write the name and formula of some molecules of any substances. It can where the molecule is made up of same type of atom, and the molecule is made up of different types of atoms. Characteristics of particles of matter. So particles of matter are very small, they are very tiny, they are invisible to the naked eye. Even many microscopes cannot be used to see the particles of matter. We need very high quality microscopes, which are called the scanning tunneling microscopes, through which we see particles of matter. Particles of matter have space between them. The space between the particles of matter are called interparticle or intermolecular space. So any particle of matter will have some space between them. The space may not be same in all types of matter. Some may have more space, some may have less space, but whatever, some amount of space will always be available, and this space is called interparticle or intermolecular space. Particles of matter are in constant random motion, so they are constantly moving about from one place to another. The particles are not like all good students who sit in one place quietly. No, they are always moving. Either they are vibrating or they are moving all about the place in a zigzag pattern, never static, never sitting down quietly in one place. Particles of matter attract each other. The force of attraction between the particles of matter holds them together and is called the intermolecular force of attraction. So there is a force of attraction between the particles of matter. One particle of matter will always be attracting another particle of matter, and this force of attraction only binds the particles together and makes them a solid substance or a liquid, and we can see them. So these particles this force keeps them in one place, all holds them together, and we call this force as intermolecular force of attraction, or sometimes interparticle force of attraction. Now we will be talking about the Brownian motion. Now if you can see this image, this shows the Brownian motion. This shows actually the movement of particles in a liquid or in a gas. On the surface of the liquid or the gas, the particles are always in constant random motion. They are not static, you can see. They are constantly moving. They are moving in a zigzag pattern, no particular order in which they are moving. This haphazard random motion of the suspended particles on the surface of liquid or in air is called Brownian motion. So if you can use a microscope and look into a sample of water, this is how you will see the particles of water are behaving. The molecules of water will be always in motion in some sort of this pattern. Now Brownian motion was actually first came to light when Robert Brown, a botanist in 1827, doing an experiment, observed that fine pollen grains on the surface of water were not stationary. So he took some pollen grains, put it on the surface of water, and these pollen grains were not stationary on the surface of water. They were moving about. He tried to observe these pollen grains with the help of his microscope, not naked eye as such, and he saw that the pollen grains were moving in a zigzag way, in a random manner. And that's when the first time we came to know about the movement of particles in liquids, but it was not at all understood well then why this was happening and how. And that around 96 years later, a scientist called Norbert Wiener explained what Brown observed. So he explained what Brown observed, and he said these pollen grains were moving only because the water particles, which are much smaller than the pollen grains and which move at a much greater speed than the pollen grains, were constantly colliding with the pollen grains, and thus that's the reason they were moving. Now we move on to the next phenomenon called diffusion. Diffusion is very common. in a day-to-day life, but let's see what is it about. First we will look into the picture and then we will go to the definition. Here we have a gas jar. This gas jar is filled with bromine vapors. So you can see these are almost reddish brown bromine vapors here. This gas jar is filled with these bromine vapors, and what we have done is these we have inverted empty gas jar, not vacuum, air is there over this bromine vapors, over the gas jar containing the bromine vapors, and then we have removed the lid. After some time, what we observe, both the gas jars are filled up with bromine vapors. Obviously the color here will be much lighter than the color here in the first gas jar. So that's what we tend to observe. So why this happens? What's the reason? The reason is there is an intermixing of particles of two or more substances taking place due to the motion of the particles. Now these bromine vapors, they are gas, they are constantly moving, they are showing a haphazard random motion, and this empty gas jar, which appears to be empty, is filled with air. So there are also oxygen molecules, nitrogen molecules, and these molecules are constantly randomly moving. So when both of these come about, these particles move and they occupy the whole place. So there is an intermixing happening. The air particles move down here, the bromine vapors move up, and an intermixing takes place, and this phenomena is called diffusion. We should know the rate of diffusion is fastest in gases and slowest in solids. So you have an activity here. Give 2 examples of diffusion from your daily life. Okay. So in your daily life, where do you observe diffusion? So you have to find out 2 such examples. Now after this, we will discuss a little bit about the factors on which rate of diffusion of a gas depends. There are 2 factors on which rate of diffusion of a gas depends, mainly at a level 1, that's temperature. If the temperature of a gas is high, the rate of diffusion is high. So rate of diffusion is directly proportional to temperature. So if you have a sample A whose temperature is maybe 20 degrees centigrade, a sample A of gas 20 degrees centigrade, and you have a sample B of the same gas whose temperature is maybe 90 degrees centigrade. The sample B will diffuse at a much faster rate than sample A. Next factor is density of a gas. Rate of diffusion is inversely proportional to the density of a gas. So if you increase the density of a gas, rate of diffusion will decrease. That means what? You have 2 gases. Let's take ammonia, is a very lighter gas. It has a vapor density about 8.5. And you take carbon dioxide, it's a heavier gas. It has a vapor density about 22. So out of these 2 gases, who will diffuse faster? It's ammonia who will diffuse faster, and carbon dioxide will take a much longer time to diffuse. So rate of diffusion is inversely proportional to the density of a gas.